Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is our next problem. Problem having been chosen from the same book, that is Modern Physics by Paul A. Tipler and another author, perhaps Leoline. Anyhow, Paul A. Tipler is enough. Okay. As usually, first come to its statement. An electron of rest energy mc square equal to 0.511 million electron volt moves with respect to the laboratory at speed u equal to 0.6 c, where c is speed of light. Okay, u equal to 0.6 c, meaning 60% of the speed of light. Okay. Under these circumstances, we are required to find a solution of 4 questions. Solution of 4 problems. Okay. Find part A gamma, with gamma, that is the Lorentz factor. Part B P in units of million electron volt over C. P means momentum. C E energy, and part D E K, where K is written as a subscript of E, that is kinetic energy. Okay. Now we come to its solution. Dear students, in order to solve this problem, we are going through some snapshots from various books. These snapshots will help us a lot, and our 4 parts will be solved in accordance with these snapshots. Okay, so first snapshot is regarding Lorentz factor. Lorentz factor gamma is equal to 1 over under root 1 minus u square over c square, where u is the speed of one frame of reference relative to another, and c is the speed of light in vacuum. Okay, our part A will be dealt with in accordance with this snapshot. Okay. Second snapshot, momentum P is equal to mu over 1 minus u square over c square. Okay. Dear students, here momentum is also a vector and velocity u is also a vector, but when u is taken in square, then it becomes scalar. Okay. Momentum P is equal to mu over 1 minus u square over c square. This is the relativistic momentum. Linear momentum is also not relativistic, because in linear momentum velocity is not approaching to speed of light. It is not comparable with speed of light. Okay. Third snapshot, relativistic energy E is equal to k plus mc square. This alternatively becomes equal to mc square over 1 minus u square over c square under root. Okay. Our first part A will be solved in accordance with snapshot. This snapshot yellow color. Part B will be solved according to this second snapshot, and part C will be dealt with in accordance with either of these 3, rather 4 snapshots, which are alternate versions. These snapshots explain similar sense, but these have been chosen from various books. Okay. So relativistic energy E equal to k plus mc square. This alternatively becomes equal to mc square over 1 minus u square over c square under root, or alternatively this snapshot is taken in this form. Okay. The total energy E of a particle is given by E equal to mc square over 1 minus u square over c square. This alternatively becomes equal to gamma into mc square, where gamma is the Lorentz factor. Okay, or third alternate version of this philosophy, this theory is that total energy of a particle E is equal to kinetic energy K plus rest energy mc square. This alternatively becomes equal to mc square over under root 1 minus v square over c square, where m is the rest mass of particle, c is the speed of light in vacuum, v is the speed of particle. Okay, and this alternatively becomes equal to gamma into mc square, where gamma is Lorentz factor relating the rest frame of particle and frame of observer. Dear students, next to this another alternate version of this snapshot is given. Okay, E equal to k plus mc square. This alternatively becomes equal to mc square over 1 minus u square over c square under root. Okay, relativistic energy. Okay, now this last snapshot deals with the last part, that is part D. First snapshot is dealing with part A, second snapshot is dealing with part B, while third, fourth, fifth or sixth, okay, third, fourth, fifth or sixth snapshot is dealing with part C, while last snapshot is dealing with part D. The relativistic expression for the kinetic energy of a particle is K equal to mc square over 1 minus u square over c square under root minus mc square. This alternatively becomes equal to gamma minus 1 mc square, where gamma is the Lorentz factor. Okay, in accordance with these four types of snapshots, we first solve part A in accordance with this yellow colored snapshot. Okay, Lorentz factor gamma is equal to 1 over 1 minus u square over c square. Okay, so here part A, gamma is equal to 1 over 1 minus u square over c square is equal to 1 over 1 minus 0.6 c whole square over c square. This alternative becomes equal to 1 over 1 minus 0.36. Okay, 1 minus 0.36 is not appropriate, 0.36 is appropriate. Actually, this c square will be cancelled out with this c square, and square of 0.6 is 0.36. When we subtract this quantity from 1, we get 0.64. Okay, and when we take under root of this quantity, we get 0.8. And when we divide 1 with 0.8, then we get 1.25. Okay, so our Lorentz factor gamma has become equal to 1.26. Now we come to part B. Part B will be solved in accordance with the second snapshot. Okay, that is relativistic momentum P is equal to mu over 1 minus u square over c square. Okay, so we come to part B. Okay, this is part B. Relativistic momentum m is equal to relativistic momentum P is equal to mu over 1 minus u square over c square. This alternative will becomes equal to this over this. Okay, what we have done, we have just put the value of m from statement. We go to statement. This is given mc square equal to this. So if we keep m on one side, then m will be equal to 0.511 million electron volt over c square. Okay, so in part B, in place of m we have used this value. Moreover, value of u is given as 0.6c, that is 60% of the speed of light over 1 minus u square over c square. We have already calculated this factor. Okay, 1 minus 0.6 c square over c square, this c square will be cancelled out with d square, c square. Okay, when 0.511 is multiplied by 0.6, we get 0.3066 million electron volt over c. because one c will be cancelled out with this c square. Okay, c square will remain single c, simply c. Okay, because c is in the numerator and c square is in the denominator. Okay, so this we have already calculated this portion, which is equal to 0.8, and hence after simplification relativistic momentum P becomes equal to 0.38 million electron volt over C. Okay. Now we come towards part C, which will be solved in accordance with snapshots 3 or 4 or 5 or 6 or 7. Okay. 3 or 4 or 5 or 6. Okay. So this is E is equal to K plus MC square. This is alternatively equal to MC square over 1 minus U square over C square, and this is alternatively equal to gamma C square. E is equal to gamma C square. We explain this portion from our snapshots. Okay, these are our snapshots. Yes. E is equal to gamma C square. E is equal to gamma C square. Here we have found the value of Lorentz factor gamma in part A. Moreover, value of MC square is given in the statement. So our part C has become quite easier, simpler. Okay. Gamma, in place of gamma we use 1.25, which we have solved in part A of this problem. Moreover, value of MC square has been given as 0.511 million electron volt in this statement. Okay, hence multiplying 1.25 into with 0.511, we will get E equal to 0.63875 million electron volt. Okay, now we come to part D, which will be solved in accordance with the last snapshot. Last snapshot is this. Okay, here dear students, in place of kinetic energy we have used the symbol K, but in our statement EK, that is K written as a subscript of E, that is kinetic energy. Okay, there is no difference between these two donations. Okay, here kinetic energy is expressed by simply K, while in our problem statement kinetic energy is denoted by EK, where K is written as subscript of E. Okay, K standing for kinetic and E standing for energy. Okay, so in accordance with this expression we will solve K not K, K or EK. Okay, K or EK, no difference. Okay, so here EK, K or EK, no difference. Kinetic energy EK, where K is written as a subscript of E, is equal to MC square over 1 minus U square over C square minus MC square. This is alternatively equal to gamma minus 1 MC square. Okay, we have found the value of gamma in part A of this problem, which is 1.25 minus 1 into MC. Value of MC square is given in the statement, which is 0.511 million electron volt. Okay, hence this factor will become 0.25. Okay, because from 1.25, when 1 will be subtracted, we will get only 0.25. Okay, and when 0.25 will be multiplied by 0.511, we will get 0.12775 million electron volt. Okay, hence our kinetic energy K or EK, where K is written as a subscript of E, becomes equal to 0.12775 million electron volt. And this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.